All right, in the last video, we described the theory that we were going to be using, and it is based on the conservation of energy as well as the conservation of momentum. So as you can see here, we have our conservation of momentum, okay? And we're going to also use the conservation of energy derived from the work energy theorem. If I pull this up, that's just saying that the energy in the initial state is equal to the energy in the final state. That's all. And so know that we drove this equation from both the conservation of energy and conservation of momentum. So let's go ahead and go to video physics here. And I've downloaded the video. The first thing that I want to do is I want to go ahead and change the name. And I'm just going to call this COM and COE. I'll put it like that. And COE, so for the conservation of momentum and the conservation of energy laws. So I want to go ahead and say initial velocity. So because that's what we're trying to calculate. And then of course your name. So I'll just say okay. So I have that. Let me go ahead and open that up. You guys are more than welcome to look at the video. It's not that long, but to look at the video and then to just kind of get an overview or to look at it for the first few seconds, kind of get an idea of what's taking place. So it's coming up, it's loading. All right, there we go. So if I just played it a little bit, calculating the initial velocity using the ballistic pendulum. And so it's just going to go on through, and you'll see here that we're going to set our origin. Let's just say we set our origin at this location here, okay, right here. And then, so that'll be our initial point, and then where it comes up here somewhere and stops, that'll be our final point. So I'm just going to go ahead and go through that. So I'm going to go ahead and pop this right here. So that's going to be the origin, okay? And we need a scale. As you can see, there are no rulers back there that are useful. I forgot to put one back here. So I went back and I measured the length from the top of the pendulum to this portion, and this is going to be 0.042 meters. So before we even begin, I'll just put this over here like so. And just in case we can't see it, I should be able to get in closer like this. So this is 0.042 meters or 4.2 centimeters. All right, so hopefully that is reasonable. And now we want to go ahead and plot our points. So just like before, I'll plot the first few. And then you guys make sure you plot all the rest. So at this point, you only need the first, and then you just need where it comes to rest. See how it comes to rest right there? Like about right here. So I'm going to try to put that line. And the only thing that we're going to be concerned with will be the Y direction. So I'm trying to use the crosshairs to localize the same point each time. So I'm just going to play it because I have to kind of settle it again. And then I'll scrub up. All right, so it looks pretty consistent there. So again, I'm going to strike and it's moving. So again, I'm using those crosshairs, the X crosshairs, to kind of try to get right on there. Okay, so let me play, move back. Tap, move this forward. And then we'll just keep going. So again, I'm causing it to rise up. See here, it looks like it's about to come back down. Okay, go back one. And I'll stop right there and you guys finish the rest of them. Make sure you have, you want to have a point at the origin and a point in the end, or a point at the final position. And you need to get all the points. So it should be 10 trials. In the next video, we'll take this information over to graphical, okay? And I'll show you how to use it again as far as calculating the height. Make sure you also upload this video to Dropbox because I will be asking you for it.